So now we have three different kinds of equations that we're working with. Linear, which would mean a straight line, which remember is my y equals mx plus b. Quadratic, which is what we're currently working with, ax squared plus bx plus c equals 0. And our exponential y equals a times b to the power of x. So we're going to be looking and trying to see if we can figure out which ones of those equations that we have. First thing is just graphing them. So I'm just going to do one of these. You're going to graph each point. So 0, -4, 1, -2, 2, 0. Oops, I went the wrong way on that one. 1, -2, 2, 0, 3, 2, 4, 4. And then I'm going to look at what I have there and see if I can figure out which kind of, what I have. Do I have linear, quadratic, or exponential? They're not lines. So if I look at this, in this section here, it's a straight line. So I would say that this is a linear graph. So you're going to try the other ones. Again, check it with the answer key just to make sure. But being able to graph those points. A data set, when we have the data sets, it's like a table, and I can do the same thing with 3 and 4. I can create them into a table, and what we're going to do is create what's called second differences. So if I want to see how far apart each of these numbers are. So in this case, from 3 to 6, I can look at either multiplying or adding. So linear and quadratic, they would be, we kind of do these differences and we would do a subtraction. And exponential, again, we're looking for multiplication. So the first thing I'm going to look at and say from 3 to 6, that's a difference of 3. And I know that from 6 to 12, it's not a difference of 3. But it is, it is that a multiplication piece. So I can look at what I'm multiplying by. If you don't happen to see that, you can go here. And then if I go again, I start to get the same pattern over and over. That tells you it's an exponential data. I'm not asking you to write an equation. I'm just saying to identify. And so if we use this idea of how far apart our numbers are, which is called second differences, and we're doing second differences because if it's quadratic, the second numbers, this list of numbers would all be the same. So by doing differences, if it's linear, all of these are the same. And all I'm doing is subtracting to see how far. So 6 minus 3, 12 minus 6, 24 minus 12 to see how far apart those are. If it's exponential, the second set will start to reproduce whatever we had in the first. Also, you might notice that it's being multiplied by a particular number. Looking at our second set, this one I'm adding 2, adding 2, adding 2. I don't really need to do a second set of differences because at this point, I know I'm at linear. The third one, and again, our x's are going up by 1s. That's important here. This one here is a difference of 4, 6, 8. So it's definitely not linear because they're not the same. But when I look at my second one, they're all the same. So the second differences is going to tell me that this is a quadratic. If that second column ends up being all the same, just like the linear was, and that has to do with the powers. So if I had a power of 3, I could do this, and the third power would be the same. So exponential, I get the same pattern, 3, 6, 12, 3, 6, would have been 12 if I could do another one. Linear, the first time, they're all going to be the same. They're all going to be adding the same or subtracting the same. Quadratic, when I do these differences, the first set aren't going to be the same, but when I do the second set, they will. If I have a list of points, I'm just going to create them into a table. So -5, 9, -4, 0, -3, 7, was it -3, -7, -2, -12. So same idea. If I put them into a table, it just makes it a lot easier to deal with. And then here, I can go ahead and do my second differences. So I went down 9, and then it went down 7, and then it went down 5 more. And if I look at my second piece, it went down 2, and it went down 2, which makes, since those two are the same, it's now quadratic. So again, try out the other ones and then check it with the answer key to make sure that you're understanding. But your first step is just going to be making it into a table. So now we have a table, and we're going to look and see if we can figure out what sort of pattern is happening here. So I can tell it's definitely not linear because I'm going from 20 to 19 to 18. So I want to be able to determine, is this an exponential model or is this a quadratic model? I could use my second differences, and to do that would say that this is going down by 1,000. This here is going down by 900. My brain is not functioning today. So 19,000 minus 18,050, 950. I would have been right. And then if I look at my last one, the 18,050, and then it's a decimal in there. So 902.5, that should be 902. If I did differences again, this one, the first one I can tell is going to be 50, the second one's not. So the only thing that's left is exponential. So that means I'm going to be writing an exponential equation. Remember, is y equals a times b to the power of x. A is my y-intercept. And in this case, b is going to be my decay rate or decay factor. So to find b, I'm going to do 19,000 divided by 20,000. And I got 0.95. And then I like to test it. I'm going to put 20,000 in my calculator and do times 0.95. And then do times 0.95. And again, just to make sure all my numbers match up. So y equals 20,000 times 0.95 to the power of x. So then I have, that would be my equation written in exponential form. After 8 years, this just means x equals 8. So in my calculator, 20,000 times 0.95 to the power of 8. And I could just keep going on my table or up above just to see what would happen. And on this one, I would get 13,268.41. I'm going to round it for money. And then we have one more where we have a table of values. So again, I'm going to look at it and kind of see if I can figure out that pattern. And I'm just going to use those differences. So this one goes up by 750. So then 16,500 minus 15,750. And this one also went up by 750. So at this point, it should be linear. Let's just check the last one. And 750. So that first differences happens to all be the same, which means it's linear. And remember, linear is y equals mx plus b. M is your slope, or that's how much we're changing by, so 750. And this is the y-intercept. And that y-intercept happens when year 0 or x equals 0. So y equals 15,000 plus 750x. Or you could have had 750x plus 15,000. I just wrote the 15,000 first. After 10 years, so x equals 10. So y would equal 750 times 10. If I wrote the equation the other way. And I would just type that into my calculator to get 22,500. So you just want to check the other answers on to make sure that you understand it, and you're good.